All right, welcome everyone. We've got a fantastic explainer lined up today. We're diving headfirst into the chemistry of everyday consumer products. We're taking science right out of the textbook and exploring the invisible, microscopic world behind our daily routines right here in Uganda. So get ready, because we're about to uncover the hidden science in absolutely everything, from your bathroom wash basin straight to your kitchen pantry.
Let me ask you a quick question. When you're scrubbing your laundry, do you know what's actually getting your clothes clean? It's so easy to just assume it's the physical friction, right? Just your hands doing the hard work. But honestly, your everyday actions rely on these intense, microscopic molecular battles. It's literally pure chemistry in motion.
So, here's our roadmap for today. We'll start with the chemistry around you, then look at how soap destroys grease. After that, we'll tackle surviving Uganda's hard water, look into the additives in your food, and finally, wrap up with your environmental impact.
Section 1. The chemistry around you.
It's absolutely crucial to realize that we're interacting with these consumer chemicals constantly. This isn't just stuff happening in a lab, it's happening right in your home. From the soap you use in your morning shower to the salt and preservatives in your breakfast, chemistry is literally everywhere. And look, the goal of understanding these O-level chemistry concepts isn't just about passing an exam, it's about empowering you. When you actually understand the chemical makeup of what you eat, drink, and put on your skin, you become an informed, health-conscious consumer. You can make way better choices for your family.
Moving on to Section 2, how soap destroys grease. Let's uncover this microscopic battle that happens every single time we wash our hands or do our laundry. The whole thing starts with a foundational chemical reaction called saponification. Now, saponification is just the process of making soap by reacting natural fats or oils with a strong alkali, like caustic soda. So whether you're using locally sourced coconut oil or animal fat, this fundamental chemical transformation is exactly what creates the powerful cleaning agents we rely on every single day.
If you were to see this as a classic teacher demonstration in a lab, it usually goes like this. Step 1, you mix a small amount of vegetable oil with the concentrated sodium hydroxide solution. Step 2, you heat that mixture gently and give it a good stir. And Step 3, you add salt. The salt actually causes the newly formed soap to separate and float right to the top. Now, a quick safety note here. Sodium hydroxide is highly caustic, which is exactly why this is strictly a lab demonstration. But this simple procedure beautifully illustrates how we convert ordinary organic oils into vital cleaning products.
Now, what's really fascinating is the molecular structure of the soap itself. The core component of soap is a surfactant, and it has this sort of split personality, two very different ends. It has a hydrophilic head. Hydrophilic just means it absolutely loves water and bonds with it. But then it also has a hydrophobic tail. Now, this tail hates water, but it binds strongly to grease and oil. This dual personality, that's the secret weapon of soap.
So let's see how this actually works in action. When you add soap to water and rub it on a dirty surface, Step 1 kicks in. Those hydrophobic tails bury themselves deep into the grease just to escape the water. Then, Step 2. The hydrophilic heads point outward, desperately grabbing onto the surrounding water molecules. This creates this tiny spherical structure called a micelle. Finally, Step 3. As the water is agitated, these micelles lift the grease right off the surface and suspend it in the water. This whole process is called emulsification. Basically, the grease gets trapped in a tiny microscopic emulsion, and boom, it can simply be rinsed away. Honestly, isn't that brilliant?
All right, Section 3, surviving Uganda's hard water.
So now that we know how soap works, let's talk about a very real, very frustrating local challenge. A lot of areas in Uganda have what we call hard water. That's water rich in dissolved minerals, specifically calcium and magnesium ions. And when you try to use natural soap in hard water, this annoying chemical reaction happens. The soap molecules react with those calcium and magnesium minerals and form this gray, sticky precipitate. We usually just call it scum. And because your soap molecules are getting entirely used up just creating this scum, the soap fails to lather properly. So instead of cleaning your clothes, it often just leaves these sticky stains all over them.
The modern workaround for that problem really comes down to the chemical differences between natural soap and synthetic detergent. Natural soap comes from natural fats, and as we just saw, it fails in hard water by forming scum. Detergents, on the other hand, are a totally different story. They're synthetic chemicals, often derived from petroleum products, and they are chemically engineered specifically so they do not form precipitates with those calcium or magnesium ions. They work perfectly in hard water. But, this convenience definitely comes with a trade-off when we look at their environmental biodegradability, and we'll touch on that in just a bit.
Section 4. Additives in your food.
Okay, let's pivot from the laundry basin straight into the kitchen. We're looking beyond just cleaning products now, because every time we eat packaged goods, we are interacting with consumer chemicals. First up, think about preservatives like sodium benzoate. These are incredibly important for our food chain. They stop microorganisms like fungi and bacteria from growing, which keeps our food safe and extends its shelf life. Then you've got flavor enhancers like MSG, monosodium glutamate. But here's the big why this matters moment. Some of these artificial colors and flavor enhancers can actually trigger allergic reactions in certain people. That is exactly why making a solid habit of reading product labels is absolutely critical for your health.
And this whole concept of chemical balancing, it applies to personal care products too. Did you know that human skin and hair are naturally slightly acidic? Well, because of this, high-quality shampoos and lotions are chemically formulated with a specific, slightly acidic pH just to match our biology. If a personal care product is too alkaline, meaning the pH is just too high, it can literally strip away and disrupt your skin's natural protective barrier. So understanding a bit of chemistry actually helps you protect your own biology.
Finally, Section 5, your environmental impact. For this last section, let's kind of zoom out to the macro level. It's time to talk about the end-of-life cycle for these everyday chemicals and the real impact they have on our beautiful Ugandan ecosystems. The crucial point here is understanding what happens after the water goes down the drain. Traditional natural soaps, they're highly biodegradable. That means natural bacteria in our environment can easily break them down without causing any harm. But those synthetic detergents, the ones that work so perfectly in our hard water, are often not easily biodegradable. When they wash into local waterways, they can lead to severe pollution and completely disrupt our delicate aquatic ecosystems.
Which brings us to a really powerful quote from our source material that I definitely want you to remember. Being a consumer isn't just about buying, it's about understanding. Chemistry explains the hidden functions of absolutely everything, from the shampoo in your shower to the juice sitting in your fridge right now. When you master this kind of chemical literacy, you can make smarter, safer, and much healthier choices for your own life and your environment.
So I want to leave you with a bit of a provocative question to wrap up our explainer today. What product label are you going to check first today? Will it be your laundry detergent? Maybe your favorite snack? Take this O-level science, walk right into your kitchen or bathroom, and empower yourself by understanding the chemistry in your very own home. Thanks so much for joining me on this explainer, and definitely keep exploring the science around you.